transform and then Z transforms. We will discuss the topics related to the questions which were given in the test series. So let's start now. You must be aware with the basics of the discrete Fourier time analysis and the discrete Fourier time transform, the discrete Fourier series. So this is basically, they have mentioned few signals and then they are asking that what type of transform is suitable for them. So we will simply first find out that what type of signal it is. So this signal is basically, what is this? Discrete. Okay. Discrete plus aperiodic. Okay. So what we use? Discrete time Fourier transform. For these kind of signals, we use discrete time Fourier transform to get information about frequency. No. Okay. And this signal is periodic. This signal is periodic, one being constant. This is again periodic, cosine, sine. So this is continuous time. Okay. This is basically continuous plus periodic. Okay. For this, we will use Fourier series, which is continuous time Fourier series. Okay. For periodic signals, we use Fourier series to get the frequency domain information, and sometimes to solve in frequency domain, it's easy to analyze in frequency domains like filters and information frequency component. This signal is continuous. Let me continuous plus aperiodic. Okay. So for this, we will use continuous time Fourier transform. Continuous time Fourier transform. Okay. And this signal is again periodic, discrete plus periodic. Okay. So for this, we will use discrete time Fourier series. Okay. For periodic signals, we always use Fourier series. If signal is discrete, then we will use discrete time Fourier series. If the signal is, or signal is, suppose continuous, then we will use continuous time Fourier series. So basically this is one discrete time Fourier transform, one P will correspond to one. Okay, this two Fourier series, by default Fourier series or Fourier transform, we understand that these are continuous time, because for discrete we have already mentioned discrete. Okay, so this is again 3 and this is 4. So option this will be P will correspond to 1 and then this will 2 and then 3 and 4. So option D is correct. Okay. Extra question you can write here is that, what extra question or a good question, what will be the period of this signal? You can write, find out the period, find out the period of S. Okay, find out the period of S. Okay, this is extra question for you. You have to find out what will be the period of this. In discrete, we generally denote period by n. So what will be the period of this? Okay, this signal. Okay, now let's move to the next. Today we have to do more questions than in normal lectures. So we will be doing a little bit faster. Okay. clear everything. In second question, what they have mentioned, they have given is discrete signal, and they have mentioned that its Fourier transform is given by x omega. Okay. So first we will find the Fourier transform, discrete time Fourier transform, because this is a finite duration discrete time signal. So basically this is a discrete plus aperiodic. Okay. What is this? Discrete plus aperiodic. Okay. Discrete plus aperiodic. So we will use discrete time Fourier transform. Okay. Which is generally denoted by, let me tell you, x e to the power j omega, or they simply mention that this is, take it as x omega. So we will take it as x omega. Okay. X of omega. Okay. This we will find. We know the del n equals to 1. So this will be basically, let's do it here. Okay. This will be 2 e to the power j 2 omega. Okay. Minus e to the power j omega plus 1, then again minus e to the power minus j omega. How we are able to do it? Just using the time shifting property of discrete time Fourier transform. Okay. E to the power minus j omega, and what last term is plus 2 e to the power minus j 2 omega. Okay. So what we will do, just we will put the value of pi. Okay. Omega is equals to pi. We will simply calculate it. So this will be 2 e to the power j 2 pi, which will be, this will be 1. So multiplied by 2, it will be 2 minus e to the power j pi plus 1 minus e to the power minus j pi. Okay. Minus j pi. Then again, this will be plus 2. This is omega, no? So this will be basically e to the power minus j 2 pi. Okay. Since this will be 1, so 2, and then this will be minus 1. Okay. Minus 1. Then this will be plus 1. Then this will again be minus 1, because if you expand this, na, cos pi plus iota j sin pi, then you will get it plus 2, and this will be 1 to the power minus j 2 pi. So final will be 2, 3, 4, 5, and then 2, 7. Okay. So the answer will be 7, which is A. Okay. Now coming to the next, is basically very, they have used only two properties. One is time shifting property, and one is putting the value of this, the property of that Euler's theorem, that cos, that e to the power j theta is cos theta plus iota sin theta. Okay. Now coming to the next. Frequency response Hg omega is given by this. Now what we have to find out, the sequence Hn value at n is equals to 0. Okay. Since we know that what is the relationship between these two, if we write Hn is given by 1 upon 2 pi from minus pi to pi. Okay. Is this h e to the power j omega multiplied by e की power minus j omega and into d omega. Okay, integration with respect to the this is discrete time Fourier transform. Okay, for that what you can do, x e की power j omega. Okay, negative and this is positive. Sorry, this is plus e की power j omega t omega hn, because in the that this is basically synthesis equation. This is positive, and in the analysis equation we use the negative. Okay, when we use this, when we want to calculate this to analyze frequency domain. Okay, so simply put that n is equals to 0, and you will get it that this is simply equals to integration, okay, from minus pi to pi, integration from minus pi to pi of omega and d omega. This will become 1 because n is 0. Okay, anyway, so we have to the area divided by 2 pi. Okay, simply this is area from minus pi to pi divided by 2 pi, area over 2 pi. Okay, over 2 pi. Why do we integrate over only this 2 pi only? Because when the signal is discrete, then the in frequency domain it will be periodic. So it will having period of 2 pi. So it will repeat itself after period of 2 pi. Area over 2 pi divided by 2 pi, or you can use this method. This is basically the interpretation of this mathematical integration, or you can do the integration also. Then also you will find the same answer. Okay, method to integration. Here you can say this is the interpretation of this integration. Okay, so area over this is, we will say 1 multiplied by pi by 3. Okay, 1 into duration pi by 3. Okay, pi by 3 plus 1 multiplied by pi by 3. Okay, okay, so now divided by 2 pi and get the answer 1 by 3. Okay, in method 2 what you can do, you can just do the integration, which is very again easy to integration. Just put the limits. Okay, and do the integration because the function is constant and having value 1. So the answer is D. Now let's move to the next. You just need to remember the basic formula, and the if any there is properties there, people generally directly remember this, that area over 2 pi, this h of 0, value at n is equal to 0. But if you don't remember, then also it's easy. You just need to remember the basic formula and then put the values. Okay, now let's move to the next. What it is saying, that impulse response of a filter is given by this. The steady state filter output for an input is, okay, this can be solved by 2 methods. Okay, what you can do, we know that output yn of any system, yn of an LTI system is given by xn convolution with hn. Okay, so one method is this. You just have to do the convolution. Okay, method 1. So we will be doing simple convolution. What is xn? Xn is basically a cos n pi by 2, and we have to convolve it with this sequence. Okay, hn, I'm writing hn only. So let's remove it and simply write convolution with hn. Okay, when I can, Hn is basically impulse and then the shifted version of impulse. Okay, so the convolution is very easy. If we convolve with del n, then we will get it a cos n pi by 2 signal as it is. Then in the second, what we will get this 2a, okay, and then cos n will be replaced by n by 2, okay, due to this property of this convolution property of the impulse. Okay, so we will replace simply n by n by 2. Okay, so I'm just replacing n minus 2 multiplied by pi by 2. Okay, this is our basic signal. Here I'm replacing n by n minus 2. Okay, and the third is a cos n will be replaced by n minus 4 multiplied by pi by 2. Okay, so on solving, what you will get a cos n pi by 2. Okay, a cos n pi by 2 plus, just simplify it, you will get it 2a cos n pi by 2. Okay, n pi by 2 minus pi. Okay, similarly here you will get a cos n pi by 2, and what will be the minus 2 pi. Okay, on simplifying, this will be simply cos pi minus theta will be minus of this theta. Okay, so this is basically a cos n pi by 2. This will be minus 2a cos n pi by 2. Okay, cos of minus theta is cos theta and cos of pi minus theta is minus cos theta. Okay, using those properties of trigonometric functions, and this will be plus a cos 2 pi minus theta is cos theta, so cos n pi by 2. Okay, so this will result in 0. In method 2, you can do, you just do find out y, that h omega. Okay, h of omega, which is very easy. Let me write, this is 1 plus 2 e की power minus j 2 omega plus e की power minus j 4 omega, and just put omega is equals to pi by 2. Okay, h of pi by 2, which will be 0. Then you can say the y omega will be 0, so yn will be 0. Okay, this is method 2 is we are solving using frequency domain analysis. Okay, so when putting pi by 2, this will become, what will pi by 2, this will be pi. Okay, simply, so this will become minus 2 simply, and then plus this will become 2 pi, so this will be 1, so h omega will be 0, and since y omega is equals to h omega to x omega. Okay, so y omega is 0. From here, what you can say that yn will be 0. Okay, so I've done using method 2 also. Okay, now let's move to the next question. Okay, in this they have mentioned that xn is having discrete time Fourier transform x e to the power j omega, and then the value of n square x square n. This again can be done by two methods. Okay, method 1 we will be doing by method 1, and I will just brief about second method. Okay, so first is simply just by definition and by this, what this is asking, anyone can do. What we can do, this is our signal, and we have to sum, multiply by, and we have to multiply its square by time duration. Okay, so which is basically, since it is starting from n is equals to 0, okay, n is equals to 0, here n is equals to 0, then here n is equals to 1, n is equals to 2, 3, 4, till n is equals to 4, we have to sum out. Okay, since the signal is very small and finite duration, so we can do simply by doing mathematical calculation. If the signal is, having infinite duration, in that case we will go by the second method, which is integration property. Okay, so simply we will be doing that 0 square multiplied by 3 square plus 1 square multiplied by n square, and xn की value is also 1. Okay, multiplied by 1 square plus 2 square, and the value of that is minus 4 square. Okay, this minus 4. Then next is 3 square. Okay, and then value of that is 6 square. Okay, 3, and then again 4 square, and what is the value of signal at n is equals to 4? It's 2. Okay, so we will simply say 2 square. So what it will be, 1 plus 4, and this is 16, so 64 plus this is what, 9 multiplied by 36. Okay, plus this is again 16 multiplied by 4, 64. So this will be simply, we can say 128 plus what will be this, 9 6 is 54, 5 9 3 is 27 plus 5. Okay, 3 to 4, I added already this. So now coming to, it will become 4 5 3. Okay, so the final answer is this D. Let's move to the next. Sorry, let me just brief about the second method also. Okay, in second method, what you can do, method 2. Okay, in method 2, just hi Ajay, good evening. What we can do in method 2, this we just use, we can use the that integration property and area property. Okay, we have to use the two properties basically. First is this double difference is x square n. Okay, what you can do, that simply xn is having x e की power j omega. Okay, I will just brief. Okay, not completely solve using method 2. So we can just find out the, we will just consider any sequence Zn. Okay, which is equals to x square n. Okay, so we will find out discrete time Fourier transform according to this series for Zn, which we will call z e की power j omega. Okay, and then then again we will find out n Zn, which is basically differentiation. Okay, if you know the differentiation property, then this is basically differentiation in frequency domain. Okay, so this will be simply j dx, sorry, d, we are using z now, so we will simply say dz e की power j omega, or let me say, because any sequence you can consider yn, zn, mn. Okay, so with respect to the this d omega. Okay. Then again we have to do the double differentiation. We will what we'll do again. Okay, n square and zn. Zn is equals to x square n. Then we will use the Fourier transform for that. Okay, we will find out it. And since the summation over this summations in time domain is equals to, which is basically integration property, or you can say central ordinate theorem if you know. So summation in time domain will be simply equals to the this Fourier transform. Okay, put just omega is equals to 0 and you will get the answer. Okay, suppose I'm taking it, suppose let's consider it any yn. Okay, this sequence, suppose this sequence is yn na, n square zn is yn. In that case this will be y e to the power j omega. Okay, and your answer will be just put omega is equals to 0 where in y is equals to e to the power j 0. This will be your answer. Okay, because this yn summation of yn from n is equals to minus infinity to infinity will be y e to the power j omega. It is given by central ordinate theorem, so you will again get the same answer. Okay, let's move because we have to do more questions today, so let's move faster. Discrete time system with input xn and output as yn is shown below. The zero input response of the system is given by. Okay, you just need to consider that this equation. Okay, so simply we can say yn is equals to, this is unit delay and this is xn. So yn is basically equals to xn, okay, plus this 0.6, okay, multiplied by y of n minus 1. Okay, so this is yn, this will be yn minus 1 here. Okay, and here it will be multiplied by 0.6 of yn minus 1. Okay, so this is basically yn. What they want to know, zero input response of the system is given by, and you just need to convert in, you can convert it to in the z transform also. So what will be that? Yz equals to xz, okay, plus 0.6 yz z inverse. Okay, if you take yz here, then it will be 1 minus 0.6 z inverse, okay, which will be equals to xz. Okay, so zero input response, we have not to calculate the the force response or the zero state response. We have to calculate zero input response. Okay, so that will be defined by this differential equation, and this will be basically, we can say yn is that we have to take the inverse z transform of what? Yz. Okay, yz basically 1 upon, this will be the yz na, xz upon 1 minus 0.6 z inverse. Okay, and we have to calculate zero input response. So we will, what we will do, we will not take input anything, we will just use this characteristic equation. So output for this characteristic equation will be yn will be, we already know that any constant c multiplied, this is basically 0.6, okay, an multiplied by un. Okay, the inverse z transform of this signal, considering this xz is is 1, or you need not to consider this because they have mentioned zero input. So we will just consider this characteristic equation. That's why we have considered this constant. And now what we will do, that we will find out the value at n is equals to minus 1 to calculate this constant c. So for at n is equals to minus 1, y of minus 1, okay, y of minus 1 into 2, which is basically c multiplied by 0.6 raised to the power -1. Okay, here. So we will calculate this. Basically constant C, we can easily calculate the 2 multiplied by 0.6. Okay, 2 multiplied by 0.6. So you can say C is equals to 2 multiplied by 0.6. Okay, so this is inverse now. It will become, in that case, what you can say, yn will be just put the value of this 2 0.6 raised to the power n plus 1, okay, into un. Basically they should have mentioned initial condition, and then we have to take care of those. Okay, so this will be the answer, 2 into 0.6 raised to the power n plus 1 un. Okay, let's move to the next. Coming to the next, it is saying they mentioned xn 4-point DFT of this xn. Okay, 4-point DFT of xn, then DFT of x. This is basically again the shifting property, but in DFT what we do, what is the basic property of this discrete DFT? What is there, that xn, okay, xn and xk both are periodic with this period n. Okay, endpoint DFT, but if we talk about endpoint DFT, then this will be the periodic. Okay, both will be periodic with period n. Okay, periodic with period n, periodic with period n. Okay, so this is the basic thing. Okay, so we need to store only the n consecutive samples in this domain and in this domain, and that's why we use circular shift. Okay, because linear shift of the periodic signal is equals to the circular shift of this finite duration signal. Okay, of n consecutive samples, circular. That's why we use circular shift. This is the only thing. And you can say this xn is basically xn multiplied by this. You can say e to the power j pi by 2 n plus e to the power minus j pi by 2 multiplied by n divided by 2. Okay, so for that we have to find out the xk. Okay, xn is having DFT xk, and we have to find out for this. So this will be basically, this is basically shift in the this k domain or the frequency domain. Okay, here you have to replace 2 pi by n, then you will know that the shift is, let me just write one more step. Just send, I'm just so okay, this is basically, you can write it e to the power j 2 pi by 4. This is n. Okay, 4-point DFT, n-point DFT. Okay, multiplied by n. From here we will get to know that the shifting has taken place by 1 in frequency domain, this k domain. Okay, 2 pi by 4 multiplied by n, okay, divided by 2. From there we can say that this will be x of k minus 1, okay, plus x of k plus 1 divided by 2. Okay. Using the shifting property of the DFT, you can simply say, so what will be our answer? Thus we will shift. Okay, so I'm shifting. Okay, this is our signal now, so I will just right shift it. So what it will be? 1 minus j, because the last term will come here na, circular shift. This will go here, this, okay, this will come here in right shift, this will go here, this will go here, and this will come here. Okay, so 1 minus j comma 0, then what will be the next? 1 plus j, and then it will be 1. Okay, this is our first, and we have to sum it with what is the second? We have to, this is the right shifting and this is left shifting. Again we will repeat it in reverse direction. This 1 plus j will come here, 0 will come here. Okay, so we will start with 1 plus j, then 1, then 1 minus j, and then 0, and we have to just divide it by 2. We have to add for each corresponding to 1 minus j with 1 plus j, and then, so what we will get? 1 minus j, 1 plus j, this will be 2 divided by 2, so we will get 1. Okay, on solving this, I'm just getting this arrow. 1, then 0, and this 1, this will become 1 by 2. Okay, then next 1 plus j and 1 minus j, again they will be 2 and divided by 2, so it will become 1. Then for last 1 plus 0, 1 divided by 2, this will be 1 by 2. 1, 1 by 2, 1, 1 by 2. So this will be the answer. Okay, now let's move to the next. You are given with 4-point sequences. Okay, finite duration, 4-point sequences, this and this, then the DFT yk in terms of xk. This is again the similar to the last question we have done. We just need to find out that what is the shifting here, and which is left shift or right shift, left circular shift or right circular shift. We can easily see that this has come here, this has come here, this has come here, and this has gone there. Okay, this is basically left shifting. Okay, what do you mean that yn is equals to x of n plus 1? Okay, left circular shift by 1. So in that case, this will come here, this will come here, this will come here, and this one will go here. So we can say yk will be, okay, xk multiplied by e की power j, okay, 1, okay, k omega k omega is basically 2 pi by n. Okay, this is shifting by 1. Okay, I mentioned it here 1. And what we know, simply we can write it as x e की power minus j 2 pi by n raised to the power minus k. Okay, this will be same, and this is known as w. This we use in fast Fourier transform and DFT also, FT and DFT both. So this is, we can say w 4 is 4 point DFT we are considering, raised to the power minus k, so basically 1k. So let me simply write 1 here, 1k, or you can say simply, let's just remove the, we need not to show that 1 here. Okay, so we'll simply write this raised to the power minus k. Okay, if there is any other shifting, suppose this is 3k, then we can mention 3k or like that. So this is 2 4 multiplied by xk, so this will be the yk. What is the important thing? You just need to remember what is the base, which is wn, which is denoted like that, e की power minus j 2 pi by n. Okay, and since 4 point DFT, so we will use e की power minus j 2 pi by 4 in our case. Okay, so n will be 4. So what will the our answer? This will be our answer A, similar to the last question. Now let's move to the next. Okay, what, this is again the basic question, or you can say conceptual question in DFT. Okay, what they are saying, that two finite duration sequences or signals are there. One is having duration 5, other is having length of 8 or duration of 8. Linear convolution of there is a property in DFT. Okay, discrete Fourier transform. What the property says, that linear convolution can be obtained by zero padding these samples. And what we do, that to calculate this circular convolution, both have same duration. Okay, and we know that linear convolution will be having duration. Okay, linear convolution duration. Okay, duration or length, you can say duration or length, which is given by, suppose one signal is having length L, other is having M minus 1. This we can basically calculate using that basic funda I told you in the first or second lecture, that starting of the yn is equals to starting of xn plus hn, and ending of yn is equals to ending of that xn and hn, whatever the convolving sequences are there. If x1n and x2n, then starting of yn is equals to x1n plus x2n. Similarly, ending of these two, yn will be sum of these two, ending of these two. Okay, so this is basically, that's why we do zero padding. So what will be the duration of that linear convolution? 5 plus 8, okay, minus 1, which is 12. Okay, so we need 12 points. Okay, we have to calculate 12 point DFT. Okay, 12 point DFT, or we can say 12 point circular, 12 point DFT, and then circular convolution, DFT and circular convolution. Okay, circular convolution. Okay, so what we will be doing, zero padding. So here we will add 7 zeros, and here we will add 4 zeros. Then we will be easily able to calculate the linear convolution using this circular convolution of these padded sequences. Okay, so in that case, circular convolution with zero padding is equals to, with zero padding is equals to linear convolution. Okay, linear convolution. 12 point DFT or circular convolution. Okay, DFT I've just mentioned. Suppose if we need to calculate, in that case we will calculate DFT. Here we just need to calculate the circular convolution of 12 points. Okay, which you must know that there is circular shift in the circular convolution. We can easily calculate using the matrix multiplication. So now let's move to the next. This we have done. Okay. This is again based on the properties. What the property says. This is basically the, you can say, energy property or the Parseval theorem. Okay. In that you can say n is equals to minus infinity to infinity x square, and this is basically energy of the discrete signal, which is given by 1 upon what is the duration, or you can say endpoint DFT. Suppose we are considering, in that case, summation k is equals to 0 to n minus 1. Okay. What is given by xk of this xk square. Okay. This is given like that. You can say simply, so in that case, what will be it? You just need to we have to calculate the value of this. So we'll multiply it n. Okay. Multiplied by summation x n mod square. Okay. This will be our answer. So you can simply say, in our case, there are 8 points. Okay. This is 0, 0 to n minus 1. Okay. So 8 multiplied by, okay. Or let me just write it equals to this. This will be k is equals to 0 to 7 x of k mod square. So this will be basically 8. There is basically 8-point DFT we are considering, or 8-point sequence, multiplied by this square 1 plus 1 plus 1 8 times. Okay. This will go like that, which will be 8. So the final answer will be 64. Okay. This will be our answer. Okay. Let's clear and move to the next. Now we are coming to the Laplace transform. Okay. What they mentioned in this question, you just need to make some, kind of little bit correction. Laplace transform periodic function. Okay, ft. This is basically your function. Okay. And what the question want to say, that this function is like that. Okay. ft. This is 0 and this is a, and this function is then repeating itself. Okay. In this domain, it's repeating. Okay. So let me just draw. Okay. This is how it's repeating. So you just need to say that it's a kind of periodic, not periodic exactly, but periodic kind of signal. Okay. Then only we can say, in that case, what we can say, that Laplace transform of this whole signal, this complete signal, will be given by complete signal fs will be Laplace transform of this signal, small signal. Okay. Upon 1 minus e की power ts. Okay. And what is the, suppose we consider it as a any signal. Okay, fs. Suppose let's just take it another convention. I'm taking the whole signal as access. Okay. So this will be fs upon 1 minus e to the power minus t by s. Okay. In that case, what we can do, we just need to calculate this, the Fourier transform, Laplace transform of this signal only. Then we will calculate for the whole repetitive kind of signal or the periodic signal. Okay. So in this case, our fs, okay, for this signal only, for this small signal, fs is, we can say, since ft is, this signal, small one. So let's first write ft, then we will just calculate. ft is basically t, okay, multiplied by u of t minus u of t minus a. Okay, this signal. So fs, okay, we can write the tut. What will be this? Laplace transform tut 1 upon s square. Then minus this we can express as tut minus 1 a. So we will just add 1a and we will subtract. What I mean to say that it's just a simple mathematics. I'm just solving it using the properties. You can solve it using the integration also. Find the Laplace transform using the integration, basic definition. Okay. What I'm just doing is u of t. And okay. This signal is basically u of t. Okay. Minus this t I'm writing like that. Minus ta plus a. Okay. This is same again. This is basically t multiplied by u of t minus a. Why I'm doing like this? Because this t minus a I will multiply with this and we will use the shifting property of the Laplace transform. Okay. So in that case, this t minus a, ut minus a will be having Laplace transform e to the power minus as upon s square. Okay. And this minus will come again, this minus a, ut minus a. Okay. Which will be having Laplace transform a upon this is basically ut divided by s, and there is shifting, so e to the power minus as. Okay, got it. Now what will be the Laplace transform here? 1 e to the power minus as upon s square plus this minus a e to the power minus as divided by s. Okay, this you need to just this is basically rearrangement, or you can say simplification. I've just wrote the t by t minus a plus a because I know that this is shifted version of ut. So this is t minus a, ut minus a. I can directly write e to the power minus as upon s square. Similarly, this a multiplied ut minus a will be having Laplace transform since ut is having 1 upon s. So a upon a ut will be having a upon s, and this shifting is there t minus a. So e to the power minus a minus s. Now just put it fs here, and we will get the answer. This t is basically period. So period here they have mentioned a. Okay, this t is basically period, repetitive kind of signal or periodic kind of signal. So we can say that our final answer access, okay, will be, I just need to divide by e to the power 1 minus as. So it will be 1 upon s square. Well, this will cancel out. Minus a e to the power minus a of s divided by s multiplied 1 minus e to the power minus as. I just need to divide by this. Okay, with replacing t is equals to a. So 1 upon s square, a e to the power minus as upon s, 1 minus e to the power as. Which option is correct? This, I think C is correct. Okay. Okay, now let's move to the next. This is again easy. Most of the questions you can always solve by two methods. One is using properties or any, analysis you have done, and the other is basic definition given by integration. Okay. So here again, let me just tell you method one. What is that method? Since first we will use the method of this del 2t definition, which is scaling in impulse, which is given by 1/2 del of t. Okay. So Laplace transform, this will be 1/2. Okay. Laplace transform. Okay. Laplace transform. Similarly, we will say 2t. 2t will be u2t will be equals to u of t. Okay. You can just do this scaling in ut, then you will find out that u2t and ut are same. Okay. So for that, it will be 1/s. Okay. So the answer will be 1/2 and 1/s b. In method 2, what you can do, you can just use that definition of x of at. Suppose I am doing scaling in time domain, then the Laplace transform will be 1/a x of s by a. Okay. So from that case, we can say that del of 2t will be having 1/2 and Laplace transform del t, which is 1. Okay. Which is 1. Similarly, for u2t, okay, what you can say that 1/2 and Laplace transform of ut. Okay. Which is 1/s, and you have to replace s by s/2. Okay. s/2. Okay. Laplace transform of ut. Okay. X replace s by s/a. So again, you will get is equals to 1/s. Okay. So the final answer will be 1/2 and 1/s. Now let's move to the next. This we have done. This is basically Fourier transform, related to the Fourier transform this signal. Okay. Continuous time Fourier transform can be obtained from Laplace transform by replacing this. This is basically s is equals to 0 line or sigma is equals to 0 line. Okay. We can do this replacement whenever the region of convergence include this. Okay. So first we will find out the Fourier transform of the signal can be obtained from its Laplace transform by replacing s is equals to j omega. Okay. So first we will find its Laplace transform. Okay. What will be its Laplace transform? 1/s plus 2. Okay. Everyone know this, where the convergence is given by sigma must be greater than -2. Okay. Region of convergence, ROC. Okay. So basically this ROC is including this axis now, or j omega axis. Okay. J omega sigma, and this is our ROC. Suppose this is there now. So parallel strip, this is our region of convergence. Sigma greater than -2. Because the right sided signals have ROC right to the rightmost pole, and the pole is located as s is equals to -2. Here the pole is located, so ROC will be right to the rightmost pole. So this is our ROC. Since whenever the ROC includes this j omega axis, okay, j omega axis, which is j omega axis, is basically sigma is equals to 0. Okay. In other words, you can say j omega axis. Sigma, whenever sigma is 0, na, this is sigma 0, this is sigma negative. Okay. So sigma 0 means this line, j omega axis. Okay. So whenever ROC include this j omega axis, in that case, we can determine the Fourier transform by replacing S is equals to j omega. This is true because this is including this. But what it is saying, the region of convergence in the S plane does not include. It is including. So this is false. Okay. This statement is false. This is true. And this is false. So which is correct? D. Okay. This is true and this is false. Since it is including it, if it is true, suppose they have mentioned it like that, that region of convergence include the j omega axis or sigma is equals to 0 line, in that case, it would have been the correct explanation also. This have been true and the correct explanation also. Because the Laplace transform is converging, and we, in that case, signal is stable, so we can obtain Fourier transform by replacing S is equals to j omega. Now let's move to the next. Fs S plus S then S plus. Everyone knows that initial value theorem and the final value theorem, but what you must remember, that when they are applicable. Okay, so this is basically final value theorem. Okay, final value theorem. So to apply this theorem, what we know, that SFS, suppose I have to determine ft at t is equals to infinity, this must have okay, this must have all the poles in left hand side of S plane. Okay, strictly means pole should not lie on j omega axis also. They should be strictly in the left. They should not lie on j omega axis or sigma is equals to 0 and also strictly. Okay, this is the condition to apply final value theorem. In our case, what is SFS? SFS is basically S multiplied by S plus 5, okay, divided by S plus 1, S square plus 4, okay. So this is having two poles on j omega axis, okay. I draw one pole is here at -1, okay, and two poles are here. So we cannot use final value theorem, so we cannot define, okay. So this will be basically undefined, okay. Final value theorem cannot be used. This is from answer from final value theorem. What if we do the reverse calculation? Okay, Laplace Fs is Laplace transform of Ft. Suppose we calculate Ft by using inverse Laplace transform of that signal. Okay, inverse Laplace transform of Fs. Okay, of Fs. In that case, what you will get? We will do A upon S plus 1 plus B upon S square plus 4. Okay. And when we will be doing in that inverse Laplace transform, then we will get e to the power minus t u of t, and this we will get b sine of 2t. Okay. Sine of 2t or whatever, this 2 is here also, no? S upon S square plus A square, and A is also there. So B by 2 or like that. Okay, constant. So this is basically undetermined. This is method 2 now. From method 2 also you can say that it will be undefined or undetermined, because sine 2t, when t is tending to infinity, we cannot say it will be from -1 to 1. We cannot say its exact value. Okay, because sine is repeating now, like that. So we cannot say at infinity what value it will be having, whether 1 or -1 or 0. What. So that's why we are saying undefined. Method 2, method 1, this is final value theorem is not applicable. So you must remember, not only remember the theorems, but must remember that what under what conditions they are applicable. Okay. So terms and conditions are must. Now let's move to the next. Laplace transform of continuous time signal xt is given by xs if the Fourier transform of the signal exists. This is most important thing. What they have said, Fourier transform exists means the ROC includes j omega axis. Okay, because Fourier transform exists for stable signals only. Okay, so ROC must include j omega axis. St. So they mentioned that ROC must include j omega axis. Then we have to just calculate. So what we will do, axis we can write 5 minus s, and this we will do some breakup. Okay, so this will be s minus 2. Okay, basically factor of this binomial. Okay, or you can say quadratic equation. Okay, what will be the other? S minus 2s and minus s. So we will take -1 out now. +1. Okay, this will be s square minus 2s, then plus s minus s and -2. So we will just find out the coefficient value of the constant. As we will put s is equals to 2. When putting s is equals to 2, this will become 3 and 3 also. So this will be 1. And then for another, we will just again calculate. Okay, this is basically s plus 1. Okay, so we'll put s is equals to -1 now. S is equals to -1, then it will become -1 and 6, and this will become -3. So it will become -2. And we have already have information about ROC, that Fourier transform exists. So ROC must include j omega axis. What that means, that one pole is there here at 2. Okay, this is sigma and this is j omega. One pole is at s is equals to 2. Okay, and another is at s is equals to -1. Okay, so ROC must include means ROC must be this only. Okay, this region we can say ROC must be this region only. Okay, from -1 to 1, 2. Okay, this is 2. Okay, so for that this signal must be left sided. Okay, then only, because for left sided signals ROC is left to the leftmost pole. So this signal must be left sided. Only in that case the ROC will be left to the leftmost pole. So in that case we can write that its Laplace transform will be e to the power minus e to the power 2t. Okay, and multiplied by u of minus t. For this is already -2. Okay, -2 and e to the power, this must be right sided now, e to the power minus t and u of t. This we can write from using the standard definition for standard signal, or using the time reversal property. Okay, so e to the power 2t u of minus t minus 2 e to the power minus 2 dt. So which is correct? E to the power minus 2t ut minus t. This is again minus. So C is correct. Okay. So the C is correct answer to e to the power minus t t. Now let's move to the next. Laplace transform of a signal is defined with the region of convergence. The value of K1 for the signals. Okay. They simply mentioned that ROC is defined like this. Okay. From K1 to K2. Real of S, which is sigma. Okay. The value of K1, we have to determine this value. T e to the power minus t t ut. Okay. Suppose we can say that T u of t is having Laplace transform 1 upon, you can say, s square. Okay. Tut. It is sigma greater than 0. We will do some shifting here. Okay. What we can say, simply say that s plus 1 square shifting in the s domain will result multiplied by this e to the power minus t. Okay. So this will be e to the power minus t u of t. In that case, this sigma will be replaced by this sigma plus 1. Okay. So what will be the sigma must be greater than minus 1. Okay. ROC changes due to the time shifting because this pole location has changed now. So sigma must be greater than minus 1. Similarly, for this, we can find out, because for cos t, we are having 1 upon s square plus s upon s square plus a square. Okay. So again, shifting is there now, e to the power minus 3t. So for this, okay, for b, we can similarly say that sigma must be greater than minus 3. Okay. And similarly for these signals, we can say sigma must be greater than c. For c, sigma must be greater than 0. Okay. And for d, we can say sigma must be greater than plus 2. Okay. You just need to find out the Laplace transform. You can easily do t square, and then this is due to the shifting in s domain. Okay. And simply we know for this, and we also know for this, we have to just do the shifting in s domain. Likewise, I have done for a na. You can easily do for others. And we have to mention in the order. Okay. So K1 is highest for D. Okay. D, then C, and then A, and then B. Okay. D, C, A, B. D, C, A, B. So answer is D. Okay. Because it is having highest value for D, and then C, and then for A, and then for this. D, C, A, and B. Let's move to the next. Okay. This is again a conceptual questions. Theoretical kind of question. Okay. The Laplace transform of del t is 1. The Laplace transform of ut is 1 by s. Del t is dut by dt. Okay. Basically properties, we know this. Laplace transform of del t is this. Okay. 1. Everyone knows this. Okay. And we also know this, that Laplace transform of ut is 1 by s. Okay. And we know this also, del t, the differentiation of this. So Laplace transform of this, we can say, if we convert in the s domain, na? So Laplace transform will be s differentiation. You can say s multiplied by u of s. Okay, capital, let me write it capital US. That s multiplied by u of s. U of s we know 1 by s and s. Both a and r are true. This is also true. This is also true. Both are true. Yes, we can say the correct explanation also. Why this is? Because to get the Laplace transform of del t, we will use the differentiation property, then we can get it. So both are true and the correct explanation also. Okay, so we can say A is the answer. We can use this explanation to get it. So this is correctly explaining this. So we can say this is the explanation. Now let's go to the next. This is again the use of property. Okay, ft is given by fs. Okay, ft Laplace transform is given by fs, which is given by ln s plus 1 upon s plus 2. Okay, good evening, Pramod. Since we know the differentiation property, na? So what we know by the differentiation property, that Laplace transform of TFT. Okay, whenever there is logarithmic or other kind of functions, then we use most probably we use the differentiation property. Okay, so in differentiation property, whenever this is multiplied by this na t, so in that case this is given by minus 1. Okay, differentiation d by ds of this. Okay, whatever fs, you can say fs or this function given by the. So in that case, we can say minus 1 differentiation of this L and s upon s plus 1. Okay, and this minus upon minus s plus 2. Okay, logarithmic of x ln x 1 upon x. Okay, similarly, and then we will use the inverse of this. Okay, TFT. So now we will use this inverse Laplace transform. So TFT is equals to, inverse Laplace transform of these two. So which will be e power minus 2t. Okay, u of t and minus e power minus t u of t. Okay, this minus I've taken inside. So now ft we can easily say e power minus 2t minus e power minus t divided by t. Okay, so A is the correct answer. Now coming to the next. System described by differential equation is initially at rest. Okay, it's very easy. What we can do, we can use the Laplace transform to convert this differential equation to the mathematical equation, which will be they mentioned that system is initially at rest, so we will take initial conditions at 0. Okay, 0 initial conditions. So we will simply say s square ys plus 4 s ys using the differentiation property of Laplace transform, which will be equals to the x of s. Okay, and we will simply say ys is equals to the x of s divided by s square plus 4s, or you can say s upon s plus 4. Okay, we will take s outside. Okay, and xs we know 2, because 2 del t is having 1, so 2 upon s plus 4. Now we will do just partial fraction, or partial factorization of these two. So s, the constant we can determine putting s is equals to 0, so it will be half plus, when we will put s is equals to minus 4. Okay, minus 4 in that case, this will be again minus 0.5 minus half. Okay, this will be value for s plus 4. Oh, we have made a mistake. They have not mentioned this differentiation, so this will be, there will be no s, so we have to correct it. Okay, so let me correct it. This, there will be no s. Okay, let me put it using different color. Okay, there will be no s here, so this will be s square plus 4. Okay, simply it will be s square plus 4. There will be no s because they have not mentioned any differentiation here, so this will be simply 4ys. Okay, and here again s square plus 4. Okay, so these are also not wrong. Now we will solve again using the same. Initially I took it at differentiation, that's why I mentioned s, but there will be no s square ys plus 4ys xs. Okay, so this is the correct. So what is the ys? Ys is 2 upon s square plus 4, which we know simply that a upon s square plus a square, which is sine of 2t. Okay, when we convert to the inverse Laplace transform, then we will get it sine 2t. Okay, so always read the question very carefully. Okay, hello Sudhanshu Raj. Now let's move to the next. LTI system with impulse response ST satisfy these differential equations. Okay, actually in these questions there are 2-3 questions which are debatable. One was that last to last question, zero input response in discrete. In the last 10 questions, I don't remember the question number, but it was saying that zero input response. Okay, similar, this question is also little bit of debatable, but you know that even the IT professor which makes gate questions in the gate papers, sometimes they also correct their answer keys because there is some error, or whenever the students have some objections to the questions and answer, then they also correct, because the interpretation of questions is sometimes different what it is meant to be, and it's different in that cases. So we'll simply use the properties of the Laplace transform. Okay, differentiation, so it will be s hs, okay, plus 2 hs. Okay, and for that we will use Laplace transform 1 upon s plus 4. Okay, For this, we will use B upon S. On solving, what we will get, that this we can easily multiply it, okay? S plus BS plus 4B divided by S plus 4 multiplied by S, and then again multiplied by this S plus 2, okay? This S plus 2. So basically this is a, if we, since B is unknown, so there should not be any cancellation of, poles or zeros. So this is S is basically B plus 1 4B. So it depends on the value of B also exactly. Suppose this is S basically. So don't get it confused with this. Suppose B is minus 1, okay? Or we say B is 0, then this S will cancel out, okay? So HS will have poles at minus 2 and minus 4. Okay, suppose B is 0. If B is 0, okay? If B is 0. In that case, HS will become like this, na? S upon this S and S will cancel out, na? Pole and 0. S plus 2 and S plus 4. So in that case, it will be having poles at S is equals to minus 2 and S is equals to minus 4. So it's a little bit debatable, but in our questions and in our test series, they have mentioned that the poles will be at S is equals to 0 and minus 4. Okay. I think they have mentioned this answer A or whatever, but it's a debatable question. So I will not mark any answer. Okay. But it's simple. You must know the method. Okay. Must know the concept and the method. Sometimes the questions, even the MIT persons also used to make mistakes in making questions, or they also make in different interpretation. So we'll move to the next. Whenever you have any doubt or any, then always take the standard textbooks as a best and correct one. Okay. Because humans can make errors due to some limitations. Okay. So now we have moved to the Z transform. Okay. What it is saying, consider this signal the ROC of Z transform. For Z transform, we know this, we can write as a, this is basically finite duration. Okay, finite duration signal or sequence. Okay, so for finite duration, we can simply say that this will be b raised to the power 0, okay, plus b raised to the power 1, okay, del of n minus 1 plus b square del of n minus 2, like that. Okay, so Z transform, when we calculate xz, we will get that this is basically constant 1. So what we will have, b raised to the power 0, this is basically del n, okay, multiplied by, so it will be having 1, okay, 1 plus bz inverse plus b square z raised to the power minus 2, okay, like that. So we will say that z is equals to, when I am putting z is equals to what, 0, this is a pole of this xz, pole, okay, this is pole of xz, and since ROC never contains or never includes any pole, So Z is equals to 0 will not be included, or for finite duration, we always know that finite duration, whenever there is finite duration sequence, okay, or signal, finite duration sequence or signal, okay. In that case, ROC is entire Z plane, possibly, okay, possibly excluding or including, hello, possibly including or excluding, okay, including oblique excluding Z is equals to 0 or infinite. For that, we have to check by just determining the Z transform, okay. So you determine that this Z is equals to 0 is a pole, so it will not include Z is equals to 0. So the ROC will be entire Z plane, means the ROC will be mod of Z greater than 0 to infinity, okay, this option. This will include infinity. So D is not correct and this is C is correct. Why? Suppose they mentioned in option C or in any other option like that, including Z, then D is also correct. If they have included this infinite, then D is also correct. But since they have not included infinite in ROC, so this D is not correct. So always take care of this, okay, equal symbols also. Whenever there is equal symbol means that ROC is including that Z is equals to 0 also. So always be careful about these. These you have to calculate by just determining that Z transform, okay. So this is our answer, okay, and this is best matched with C, okay, not D, because they have not included infinite. Now next move to the okay. Z transform they have mentioned. So we can write it as 3 raised to the power n u of n, okay, minus 2 raised to the power n u of minus n minus 1, okay. So they mentioned for n less than 0 means n is not including 0 here, 0 is included here, okay. And we have to just determine, consider Z transform, okay. So for this Z transform will be, since this is a right-sided sequence, so the ROC will be outer to the outermost pole, okay. And for this Z transform is given by 3Z inverse, because A raised to the power n un is 1 upon 1 minus AZ inverse. And for this ROC we will mention what is mod of Z must be greater than 3. And for this, what will be the Z transform? Minus due to shifting of this reversal, we will make it, this becomes positive, okay. So 1 minus 2Z inverse, okay. And the ROC is mod Z must be less than 2, because this is left-sided sequence, okay, left-sided sequence. So ROC will be to the innermost pole, okay. In Z transform we simply just tell you draw these ROC in circular forms or ring form, okay, because this is basically defined by Z, okay, a circle. Z is basically R e की power j omega, like that. So this is unit circle, suppose. So the for left-sided sequence, whenever the pole is there, that's why we are taking magnitude. This is a circle of radius 2. So the ROC will be inner to the innermost pole for left-sided, and for right-sided, ROC will be outer to the outermost pole. So here pole is 3, here pole is 2 at radius 2. Okay. And since there is no intersection of these two, mod z greater than 3 will be here somewhere outer to this circle of this radius 3. And then for this, ROC will be inner to the circle of radius having radius 2. So there is no intersection. So Z transform is not defined. Okay. They must have common ROC. So the answer is D. Okay. Now let's come to the next. This is again somewhat similar to the last one. Z transform of what is important is causal. Causal means right-sided. Okay. This means right-sided. You must be able to extract the information from the question itself. So always read question very carefully and the read questions and the options completely. Okay. Always read the questions completely and very carefully also. So this is causal means right-sided sequence is given by this. Then region of convergence is. So for this ROC is, okay, for this ROC is mod of Z greater than 0.5. Okay. And for this ROC is mod of Z greater than 0.25. Okay. And there is addition of these two signals. So ROC will be the intersection of these two. Okay. So intersection of these two will be greater than intersection. Okay. Intersection will be mod Z must be greater than 0.5. Okay. So this is true. Because this is having ROC mod Z greater than 0.5 and this is 0.25 and intersection of these two ROCs mod Z greater than 0.5. So this is true. Okay. Okay, this is true. The 0 of xz is not in the ROC. Okay, we will simply just simplify or just determine xz. Okay, then we will be able to get the answer. Though we know 1 0 is at z is equals to 0. When we put z is equals to 0, then the xz becomes 0. So 1 0 of xz is at z is equals to 0, and which is not in the ROC because ROC is greater than 0.5. Circle, a ring having radius greater than 0.5. So xz you can simplify it z minus 0.5. Okay, and z minus 0.25. Okay, just do the cross multiplication when z is already there. So this will be z minus 0.25 plus z minus 0.5. Okay, which will be, I'm just writing numerator only, denominator as it is. Okay, so numerator this will become 2z. Okay, minus this will become 0.75. Okay, from here what zeros कहाँ होंगे, z, just writing zeros, this for zeros, This is value of z. At z is equals to 0 and this will be 0.375. Okay. So both are not included in ROC. Zeros of xj is not included in ROC. Okay. This is also true. But this is not the correct explanation of that. Okay. So answer B. What is the correct explanation of that? If they mention that poles of xz are not included in ROC. Okay. Because ROC never contain any pole. In that case, it might have been the correct explanation of that assertion. Okay. So both are true, but not the correct explanation. Okay. Now, next. Again, this is causal. Periodic discrete time signal with period. This is again, let me tell you, little bit. You must not interpret in different way. Okay. This is kind of periodic. Okay. In the question from 1 to 10 also there was one signal. I think in Laplace transform also there was one signal which was having periodic. Okay. But it's similar to that. That is repetitive in nature. Okay. So basically this signal. Okay. Suppose a signal is existing from n is equals to 9 to this. Okay. 0 to 9. This is any signal. Suppose like that. Okay. From 0 to it's going 1, 2 till 9. Okay. This is n and this is basically gn. Okay. Don't count exactly. This is basically till, let me write this till 9. Okay. So 1, 2, 3, then some other signals will be here. Then this is 8 and 9, 0 to 9. Okay. Having duration of 10. Okay. So 0 is also included. Okay. Here is also some signal values there. Like that. So this is basically Gn. Xn, we have just assumed any Xn like this random, and this is Gn. What is Xn? Xn is just repetitive of that. Okay. Xn is basically Gn plus Gn minus 10. Okay. Just repeat these signals after with period 10. Okay. Gn minus 20 like that. This signal will repeat as it is from 0 to 9. Then it will repeat from 10 to okay 19. Then from again 20 to 29. It will simply repeat like this. This is basically Xn. Okay. So what we can say that Xz will be Zz plus Zz using time shifting property Z minus 10. Okay. Plus Zz Z minus 20 like that. It will go. Okay. Further. So it will be like that. Okay. So now we will use the summation. Okay. Summation of AP. So we will simply get Zz upon 1 minus Z raised to the power 10 because summation of infinite AP is 1 upon 1 minus R. Okay. Or you can say A upon 1 minus R if first term is A. But here we will take Gz out. So first term will be 1. Okay. A upon 1 minus R using this AP summation. Okay. So what will be the answer? Xz will be Gz upon 1 minus Z raised to the power 10. So C will be the correct answer. Okay. Now coming to the next. They have mentioned Z transform and they have also mentioned this. Okay. Since we know the poles are at ZP, one pole is at 0.5. Okay. And another pole is at ZP1, ZP2 is at 5 minus 5. Okay. And the ROC is inner to the innermost pole. So the signal is, then they mention ROC. So we can interpret this ROC is inner to the innermost pole. There are only two poles. This is having magnitude 5. This is having 0.5. So mod Z is less than 0.5. So ROC is inner to the innermost pole. So the signal is, or the sequence is left sided. Okay. You can say it is left sided. So left sided means should be obviously non-causal. Non-causal. Okay. And now what we have to determine, since ROC or वो include नहीं कर रही है, ROC does not include unit circle. Okay. ROC does not include, okay, unit circle. So not stable, or you can say unstable. Okay. So non-causal and unstable. In Laplace transform, whenever the ROC includes the omega axis, then the signal is stable. Similarly here, whenever the ROC includes unit circle, then only the signal will be stable. Okay. Now next, this is again similar to the last one. Okay. We can say the poles. Okay, Z poles. What are the poles? Minus 1/3 plus 1/2 and plus 2/3. They mention ROC mod Z less than 3. Okay, this ROC means inner to the innermost. This is inner, then this is outer, then this is outer. So the ROC is inner to the innermost. So again, this is left sided. Okay, left sided. So it will be non-causal. And this is does not include, okay, unit circle does not include na unit circle. Since it does not include unit circle, so it will be unstable also. Okay, so again it will be non-causal and unstable, similar to the last one. Now next, what it is saying, the Z transform of this we have to calculate. Okay, so there are again 2-3 methods, whatever you like you can do. What simply I am doing is I'm just taking 2Z square outside. Okay, in that case it can be written as, okay, if 4Z square will be there na, so 4Z square 2/4. Okay, so what I can write, 2Z divided by 4Z square 1 minus this 0.5 Z inverse. Okay, which I again can write 0.5 Z inverse upon 1 minus 0.5 Z inverse to the square. Okay. So now we will use standard definition. Okay. Some standard jet transform of standard signals, and which we already know that a raised to the power n un corresponds to 1 upon 1 minus a z inverse. Okay. Similarly, you must know that multiplied n a raised to the power n un is equals to a z inverse upon 1 minus a z inverse. Okay. This we know, and a k power n. So we will simply use this. Okay. So what is our value of this a? 0.5, which will simply say that, and let me write using this only. Okay. And a value of a is half a raised to the power n and u of n. Okay. Which we simply can write that n, and this is 2 raised to the power n and u of n. Okay. So what will be the answer? N upon 2 raised to the power n un, C. Okay. So C is the correct answer. This you can obtain using the differential property of Z transform also, which is minus Z upon differentiation of this Z, this function. Okay. Whenever we multiplied by n. Similarly, we used to do in Laplace transform whenever there is t. So we used to differentiate this, okay, with respect to the s. Here we will do with respect to the z, and there is minus z and there is minus 1 in Laplace transform. And here we will use minus z differentiation of this with respect to the z. Okay. So now coming to the next. Okay. This is again similar to the last ones. The important thing is they have mentioned stable. Stable means includes unit circle. Okay. Includes unit circle. This is important thing. So we can simply write it at using the standard definition or the standard Z transform of we have used in the last one. So we can write that as Z, can simply say that 2Z inverse 1 minus 2Z inverse. Okay. Simply write 1 by 2 here. Okay. So that this we know. So we will say that Hn will be, and since Z is equals to 2, they've already mentioned the pole, Z pole at 2, and ROC must include this unit circle. So the ROC will be mod Z must be less than 2. Okay. So we have to write the left-sided sequence for this standard signal. Okay, right-sided sequence we already know. If it would have been right-sided sequence, in that case we have okay. So what we were discussing, if it would have been right-sided sequence, in that case 1 by 2 and that 2 raised to the power n un. Okay, but since they mentioned that it is a left-sided, so we will simply write accordingly to the left-sided. So it will be 0.5. Okay, minus 0.5 into a raised to the power n. Okay, it will be 2 raised to the power n and u of minus n minus 1. Okay, for this ROC. Okay, this again you can obtain using the time reversal property, okay, and shifting property. So we will rearrange this HN because we are unable to see this as an answer directly. So we will just rearrange it. Okay, minus 0.5 2 raised to the power n and u of n minus 1. This basically signal is starting from n minus 1 to like that. Okay, it's going till infinity here in this direction. Okay, what is this? U of minus n minus 1. Okay, from minus 1 to. So we can write this signal as what we can write it as del n minus 1 and u of minus n. Okay, let me rewrite. Since this standard definition is for this signal, what is the standard Laplace transform? If this would have been square, in that case this is correct, but there is no square. Okay, so we will rewrite. So what, let me just clear it. Every 3, let's clear all. We'll just redo the answer or recalculate. Okay, so we can simply say that suppose this is 2 minus z inverse. Okay, for this we know what will be the sequence. Sequence will be 2 की power n. Okay, and u of n if it is right sided, or the sequence will be same, minus 2 की power n u of minus n minus 1 if it is left sided. Okay, this is standard Z transform for standard signals. Okay, now we will do Z inverse here. What that means, that there is n is replaced with n minus 1. So we will do that. Okay, so n is replaced with n minus 1, and here we will get u of n is replaced with n minus 1. Okay, so it will become simply minus n plus, or this will become plus 1 and minus 1 0. So u, and this will be Z inverse 1 upon 1 minus 2 Z inverse. This is if right sided. Okay, right sided, and this is if left sided. Okay, so this is the answer. Okay, but we have to rearrange it because we are unable to see this as an option. So we'll just rearrange it. 2 raised to the power n minus 1, and un we will write u of n minus 1. Okay, plus del n. We can write it. You just draw the graph of these two, you will get it. This will start from minus 1 to infinity, minus 1 to minus infinity, and this is at 0, and this is also from 0 to minus infinity. So from minus 1 to minus infinity, this is taking care, and for this 0, this del n is taking care. And now just putting this n is equals to 0, we will get 2 raised to the power minus 1, which will become 0.5. Okay, del n, and then again this. Okay, minus 1 we will taking differently 0. Because 2 raised to the power minus 1 is 0.5, and we have taken 2 raised to the power n. Okay, and then again u of minus 1 minus 1. So this is answer A. Okay, Now let's move to the next. We are left only with 2 questions. For this, we have to use the differentiation property. Okay, since logarithmic is there na, so we will simply use the differentiation property. Okay, xn is there for this log of 1 plus z inverse. Okay, so what we will do, an xn. For that, we will use this differentiation property minus z and differentiation of this with respect to z, which will be 1 upon 1 plus z inverse, and then differentiation of this z inverse 1 upon z will be minus 1 upon z square. Okay, it will be, by simplifying, we will get this minus minus plus, and this will be z inverse, okay, upon 1 plus z inverse. Okay, this is basically n x of n. Okay, and now we will calculate that n x n is basically inverse z transform of this, which will be minus 1 raised to the power n, and they mentioned ROC mod z greater than n, so right sided sequence. Okay, so a raised to the power u of n, and then this shifting is also there, so n is replaced with 1 raised to the power n minus 1 and u of n minus 1. Okay, so this is basically over n xn, n minus 1 on u of n minus 1. Okay, now we will calculate x iterate for n is equals to 1. Okay, so we will just divide n is equals to 1, means this will be 0, and n is equals to 1 is u0, which is 1, and then divided by n, which is 1, so it will be basically 1. Okay, minus 1 raised to the power 0 is 1, so answer is A. Okay, now coming to the next and last. This is very simple. Okay, you just have to multiply this. Okay, which you can say 1 plus 2z, and multiplication of these two will result into 1 minus, or let me say 1 plus 3z inverse, and then minus z inverse. Okay, multiplication of this minus z inverse minus 3z raised to the power minus 2, and final multiplication will result in this, no, simple multiplication with 1. This basically 3z inverse, and this again minus z inverse, so it will be 2z inverse. Okay, simply write it as a 2z inverse. Okay, minus 3z. So multiplying it with 1, we will write 2z inverse minus 3z minus 2. Okay, and then multiplying it with 2z, which will result in 2z. Okay, plus 4. Okay, and minus of 6z inverse. Okay, which we can write, if we go to z, okay, from positive powers to 4 plus 1 5. Okay, plus 5, and then this minus 4z inverse, this and this. Okay, and then minus 3z raised to the power minus 2. So which we can write that this is 2 del n plus 1. This is 5 del n using inverse z transform. Okay, and this is 4 del n minus 1, and this is minus 3 del n minus 2. So the sequence, this arrow basically denotes n is equals to 0. So the sequence is 2, 5, minus 4, and minus 3. Okay, and this is n is equals to 0. This is our correct answer. So this is all for today and for signal and system. If you have any doubt, you can just mention in comment section. So let's stop for today.